Okay, now let's look at temperature-pressure relationships. Recall from previous videos that if we increase temperature, okay, we're going to increase the kinetic energy. There are going to be more collisions. If there are more collisions, there's going to be a higher pressure at constant moles. And constant volume. Now, one thing you need to remember anytime you're dealing with temperature is that you have to do a conversion unless they actually are kind enough to give you your temperatures in kelvins. So, to do that, just remember you take your whatever temperature in degrees Celsius, add 273 to it, and then you'll get your temperature in Kelvin, so we can avoid zeros and negative numbers. Our first example problem: a helium tank at a pressure of 20 atmospheres and a temperature of 0 degrees Celsius is warmed to 90 degrees Celsius. What is the new pressure? So, is this helium tank going to explode? I hope not. So again, let's look at what happened and make some predictions. The initial pressure is 20 atmospheres and the initial temperature is 0. It's warmed to 90 degrees Celsius. Well, they just told us that our temperature increased. They said it was warmed to 90 degrees Celsius. So if our temperature went up, regardless of whether or not it's Celsius or Kelvin, what's going to happen to our pressure? More kinetic energy, more collisions, so our pressure is going to increase. Okay, so now let's set up our initial and final conditions. So, pressure 1, 20 atmospheres. At a temperature 1, 0 degrees Celsius. So we're going to keep it at 0 degrees Celsius? No, we're going to add 273 because if we're going to multiply by 0, we just get 0. So we add 273, and that's really 273 Kelvin. Is warmed to 90 degrees Celsius. So our second temperature is 90 degrees Celsius. 90. Again, add 273, so it's in the same units. And that is 363 Kelvin. What is the new pressure? So pressure 2 is what we're looking for. Okay, when we set up our model, we start with the variable we're looking for. So we're looking for pressure, so let's start with our 20 atmospheres. Now we're going to multiply it by a fraction or a factor that's going to make that number bigger. According to our prediction, we want our pressure to increase. So if we want it to increase and get bigger, we want to put the bigger number on top. So we put our 363 Kelvin on top, our 273 Kelvin on the bottom. Cool thing about this is Kelvins cancel out. And then if we just do the math, we get 26.6 atmospheres as our second pressure. Well, is that what we wanted to happen? We started with 20, we ended with 26.6, our pressure increased. So we can be reasonably assured that that is a correct answer. Okay, now take a moment to find your temperature-pressure relationships worksheet. Again, it's online if you don't have it with you at home. And let's look at number 1. An automobile tire has a pressure of 199 kilopascals at 20 degrees Celsius. After driving, the tire temperature rises to 80 degrees Celsius. So we want to make some predictions and we want the new pressure. This is also why it's slightly dangerous to fill up your tires when you have when it's really cold outside and you haven't driven, because when you drive, that gas is going to expand and increase the tire pressure. So in cold weather, you want to put slightly less than your tires are requiring. So what happened? Our temperature went from 20 to 80, so our temperature increased. If our temperature increases, what's going to happen to our pressure? More kinetic energy, more collisions, so therefore our pressure is going to increase. Okay, let's set up our initial and final conditions. So our initial pressure is 199 kilopascals. And our initial temperature is 20 degrees Celsius. We're going to keep it at 20 degrees Celsius even though neither number is 0 and neither number is negative. You still cannot calculate this in degrees Celsius. You can convert it back to degrees Celsius at the end of the problem if they were looking for temperature. But you have to do all of your calculations in Kelvin. So we would get 293 Kelvin. For our initial temperature, the temperature rises to 80 degrees Celsius. So temperature 2, 80 degrees Celsius plus 273. 273. You'll get 353 Kelvin for that. We are looking for our second pressure. Alright, so let's set it up. Start with the variable that you're looking for. So 199 kilopascals. And unless the problem asks you to convert it to another pressure unit, you don't really have to worry about that. Multiply it by a factor. We want our pressure to increase, so we want the bigger number on top. So we're going to put 353 on top, and we're going to put our 293 on the bottom. Again, Kelvin temperature cancels out, so our units are going to be kilopascals. And if we do our calculations, we want 3 sig figs? Alright, for 3 significant figures. Oh, this is going to be fun. So, you get 239.75. So, to 3 significant figures, let's say 240, and let's just put a decimal point there, kilopascals. If you really want to get fancy, you can go 2.40, there's our 3 sig figs, times 10 to the second kilopascals. There you go. Another successful gas law problem.